Okay guys, we're going to be talking about mode and relative frequency. This is the lesson for day 7. Data can be numerical or it can be categorical. Or it can be categorical. Which is information that is divided into groups. Mode, the pieces of data that occur more than the other pieces of data. So piece or pieces of data that occur or occurs okay. More. Mode can be thought as the value that occurs the most often. Or the category of data that is the most popular. Relative frequency, the relative frequency is the ratio of the frequency of a data point or category to the total pieces of data in the data set. It is a ratio that represents a part to whole. Relationship. It is generally represented as a decimal or a percent. I like to think the relative frequency betrays the mode, right? So whatever you get for relative frequency, whatever your highest value for relative frequency is, that will be your mode. Okay. So we can even write that here. And more specifically, mode is the object or the item with the largest relative frequency. Joshua took a survey asking his classmates the types of pets they own. The results are shown in the table. Voila. Okay. For each category, calculate the relative frequency and percent representation for each pet. Okay. So we need to start by finding the total by adding the frequency of each category. All right. So first of all, let's find out how many animals we're dealing with. So we've got 2 plus 8 plus 11 plus 3 plus 1, right? So that will be 25. So let's start here. So how many people were surveyed? Oh, excuse me. These aren't animals. These are Joshua's classmates. So these are students. So 25 students. were surveyed. So that gives us this answer down here, how many people were surveyed. And what is the mode of the data? Well, we don't know that yet. So let's say our bird. Okay, we know that there are 25 students, and 2 out of the 25 students have a bird. And I'm writing it like this because they want a ratio. 8 out of the 25 have a cat, 11 out of 25 have a dog, 3 out of 25 have a fish, and 1 out of 25 have something else. The relative frequency can be written as a decimal or percent. You can find that by doing some division here, or you can use scale factoring. I'll show you both ways, I guess. So let's say 2 over 25 if you want to get something to a percent, you want to get it over 100, okay? We're going to find the percent first, and then we're going to find it using scale factoring. We're going to find the percent by either scale factoring or by long division. And we can get rid of the word via. Just put by. Okay. So let's start here. 25 times what is 100, right? Well, that's 4. So I'm going to multiply this by 4, and what I do to the bottom, I must also do to the top. So x is going to be 22 times 4, which is 8. So now we're going to say this turns into 8 over 100. Which is equal to 8%. Okay. Percent by long division is the more straightforward way to do it. I know Michael likes this way here. This way is not always possible, or at least it's not always so straightforward. So I kind of tend to default to this method to find the percent. So we're doing the same thing for both of these. I'm just showing you 2 different ways to do it. So you just say, how many times does 25 go into 2? Top in, bottom out, right? Well, 25 goes into 2, none. So add a 0. 25 goes into 20, none. Another 0. 25 goes into 200, right? And for that, we get 8, and that goes into it exactly 8 times. So we get the same thing, 8%. Or rather, the decimal is up here. I forgot to carry up my decimal, and there would be a 0 here because 25 goes into 20 0 times. And then 25 goes into 200 8 times, and with no remainder. So my answer would be 0.08 or 8%. And I got that, guys, because if you ever want to change a decimal to a percent, you just move the decimal 2 places to the right, and that'll be your percentage right there. What is the mode of the data? Well, we don't know that yet. I did all that just to solve the first one, but I'll let you guys kind of figure out how to do the remaining 4. But it's the exact same for each one of these, and they're all over the same denominator. So for this, we have 8%, 0.08 which is equal to 8%. Here we have 0.32, which is equal to 32%. Here we have 0.44, which equals 44%. Here we have 0.12, which equals 12%. And finally, 0.04, 4%. Okay. So what is the mode of the data? Remember how I said the relative frequency betrays the mode? By betrays the mode, what I mean is the relative frequency tells you what the mode is. So the relative frequency, remember, the mode is the largest relative frequency. So what's the largest relative frequency we have, right? It's gonna be dogs. 44%, which is the highest percentage in our relative frequency list in our table here. That corresponds to dog. So dog. Go ahead and record the colors of the cars. This is a whole different problem. Okay. Gwen recorded the colors of the cars in a parking lot. Her results are shown. White 18, blue 4, black 12, silver 7, red 9. Okay. Our very first step with all of these guys is just to write each value as a ratio over the total number of cars. And then we're going to convert that decimal to a percent to find, no, we're going to convert a decimal / percent to find the relative frequency. So the very first step for these guys, whenever you're dealing with relative frequency or mode, just write them all out as fractions. So how many items do we have in total, right? So we have 18 plus 4 plus 12 plus 7 plus 9. Okay? And we're gonna work the rest of this out in class because I think you guys should have the hang of this by now. So let's just do one of this. Let's do one together.